Hey everyone, Michael Unger here with another edition of Ask an Astronomer. And as always, we are with our astronomer that is just a two doors down from me here on the unceded territory, the Musqueam, Squamish, and Tsleil-Waututh, and that is Marley. Hey Marley, how's it going?
It's good. How are you?
Not doing too bad. It is kind of warm, although it's been rainy, but summertime is here. We've got lots of
It's
clear.
it's been here, Michael.
Well, I mean, like for me, I'm more of like a fall person. So when I say
Yeah.
summertime is here, I'm actually kind of saying it might be a little bit too warm for me.
Yes.
But what that does mean is that we do have lots of clear skies. And we had fireworks last night here. And after the fireworks, you go outside and there's stars. The better fireworks in my estimation. Lots to look at. And of course, we're going to delve into lots of topics in the universe. If you are out there watching on YouTube land or on Facebook and have any question under the universe, throw it into the chat. And we have this opportunity until the half-hour mark to answer these questions. Today's episode, I have titled Asteroid Moons. And I know that Marley is going to clarify some things on this. And maybe you have some questions because I have questions on this. What exactly are we talking about? An asteroid moon? Can an asteroid have a moon? What are we talking about here, Marley?
Well, I think we've fallen into the trap of we like to categorize things, but space doesn't really care about our categories whatsoever. I think that's true in most things. Human beings love to define and put things in a box, but nature doesn't care about our boxes. So what I was meaning to talk about was that there's this really interesting update about the asteroid Dimorphos. Of course, this was coined an asteroid or like a moonlit asteroid because it orbits a larger asteroid, Didymos, right? So it's a moon, but also an asteroid moonlit. It's this thing that, we love to do, but sometimes it doesn't make sense. To give a refresher of what the Dimorphos was, is that it on September 26, 2022, NASA deliberately flew the DART spacecraft into Dimorphos, right? It was part of the kinetic energy test, right, to see if we could push something into a new orbit. So the idea was we slam the spacecraft into this moonlit asteroid and maybe knock it into a new spot. And it did. It was successful. They did successfully do that and change the orbit of this moonlit asteroid. What they found now is that they are continuing to monitor it, right, to see the long-term impacts of doing such a thing, right? If there were an asteroid that were to be near Earth, for example, and we wanted to push it out of the way, we would also like to know what potential impacts could happen, if there would be a problem. And what they found, this is an image from the Hubble Space Telescope, and they have discovered a swarm of boulders, is what they're calling this, a swarm of boulders possibly shaken off of the asteroid due to the DART impact. And so this is actually one of the articles, rarely, I guess, is an open access article. So people like to read scientific papers. You can just go read it. You don't need like a university or institution login, which I really like because then people get to look at graphs if they like them. But about these little swarm of boulders, I think that's the actual title of the paper. That's the term, swarm of boulders. There's about 37 of them, and they range in size from 1 meter to about 7 meters across-ish. So not huge, but not small. Small compared to most other things in space, but not insignificant. And they're not moving very fast. They're actually drifting away from the asteroid at about the same speed a giant tortoise walks, which is very slowly, right? So they're not, hurtling their way towards Earth or anything like that. They're just kind of slowly moving away. The total mass of the boulders, according to the paper, is about 0.1% of the mass of Dimorphos. So really not a lot has been, they're not huge, they're not big, they're not taking up a lot of space. But what's interesting is the fact that they're there, right? So it's, we've now hit this thing, and now this asteroid has been forever changed because of our impact upon it. And seeing these play out in kind of real time as we go and relook at the asteroid over the course of months and years, we'll see lots of different changes to it.
Okay, so I want to sort of paint a picture. We have this beautiful picture from Hubble here, which doesn't give us the whole picture of what you're talking about, because we have two objects. One is a moonlit, as you say.
Moonlit asteroid.
Moonlit asteroid.
Yeah.
Okay, so this is the category that we are given for this specific thing. And then we have these boulders, these swarm of boulders, which reminds me of the swarm of wasps that were coming after me when I was camping last week. But but so this swarm was just discovered? We didn't know about this swarm when DART was approaching the moonlet?
No, so this is due to the fact that we hit it, is what's
Oh,
happened. Yeah, we
okay.
hit it. And so, they don't think that it's shattered pieces of Dimorphos. They don't think we hit Dimorphos and like broke it apart. They actually think that they were already just scattered across the surface because from the very last image we got of DART, the last complete image, I should say, there was a last image that's like cut off because it impacted. But the last complete image, you can see loose rubble on the surface. Right. And so the thinking is that, the DART impacted the asteroid, and by some means, which we're not too sure yet, exactly the dynamics of what would have happened, we've knocked off boulders from the surface. And now they're just in space now, as opposed to being on the asteroid, on the moonlit asteroid itself. So yeah, Dimorphos is orbiting something bigger. And then around Dimorphos are these boulders now moving away from it. Some of them, at least the 37, I think that they've looked at, if I'm remembering the paper right, is that they're moving just faster than the escape velocity necessary. So escape velocity is how fast you need to move, how fast you need to be going to escape the force of gravity from the object that's trying to pull you in, right? So there's a set escape velocity for Earth. The rockets need to, there's all this stuff. And so these boulders are moving just a bit faster than the escape velocity of Dimorphos. So they'll eventually just leave, most likely, or something may happen with Didymos, the other one, and they'll get pulled in there. It's something to continue to study to see what happens, because we don't exactly know the trajectories that they're going to be going on, and we don't exactly know the directions from when they launched from. So what the plan is to look at it and then wait a little bit and look at it again, look a bit longer, look a couple months later, and try to gather enough data to figure out those trajectories. And you can kind of make a path back based on the movement you're seeing of where it came from, where it originated from, and that will tell them more about the impact and how it came off. We don't even know if there's like an impact crater on it yet, right? So yeah. That's possible that there is one, and that would have impacts on how these boulders came off the surface. But that's a mission for the European Space Agency's Hera mission, which is supposed to launch in 2024, I think, and arrive to the system in 2026. And it's kind of the follow-up mission. So it's going to take a relook at Dimorphos and see the changes over the time since the impact.
Very cool. So, and I wasn't aware of this, that we are going to get this second look, which will give us more information about this swarm, maybe even see remnants of the spacecraft, or is it completely obliterated?
Oh, I think it's obliterated. Yeah, I think that thing's gone. Yeah, it was moving. Yeah, I don't think there's much of it left at all. Yeah.
Okay, all right. Well, this is very exciting. So we have this moonlit asteroid that is eventually was going to come close to Earth, because that was one of the reasons that they chose this as a target.
Yeah, well, so they chose it because we could get to it, and they also chose it because there was like the smallest chance ever of us knocking it onto a path where it would future impact us, right? So it's close enough to get to, but far enough away that it's not a problem, sort of thing. Yeah.
Excellent. Okay, so that's our first story for today, and for something a little bit closer to Earth, you've got something else for us.
Yes, so this is very interesting. This is, I'm probably going to mispronounce it, Aeolus. It's a European Space Agency mission, and it is currently undergoing an assisted re-entry attempt, which is very, very cool, very interesting, that I like a lot. This is Aeolus was a mission that was launched to measure wind profiles in space in near real time. We don't really have a great understanding of, we do have a good one, but not like we could have a better one of how wind works in the atmospheres and how our atmosphere works in different aerosols and particles and things like that. And so this was the European Space Agency mission to do that. It launched back in 2018. It was actually an 11-year delay. It was supposed to launch in 2007. I think Michael left, which means I'm in control. So I'll just keep going until he comes back. This happens to him sometimes. It was a 11-year delay because of the technology they were using to do the LiDAR profile. So the instrument, there's only one instrument. Michael's back. Amazing. There's only one instrument that will be able to, that's on board. You're back.
I don't know what happens.
It's okay. There's only one instrument on board, is what I'm telling the audience. And that's why it was so delayed, because the instrument on board was like a very new type of instrument. They kind of recreated how things were working with the specific instrument. And what it does is it has a laser that fires pulses of ultraviolet light towards Earth's atmosphere, which then bounces back. And the receiver on board detects the light that's been scattered from the air molecules, water molecules, aerosols like dust. And by studying the subtle changes in the property of the light that comes back, the spacecraft and scientists are able to measure how quickly the particles are traveling away from the satellite, which tells you the speed of the wind. Right. So that was kind of what its mission purpose was. It did a very good job. It was new in terms of technology, and also new in the fact that it was looking at the entire Earth as opposed to one hemisphere or the other. Usually we have very, it's kind of segmented based on who's studying it. It orbited the Earth 16 times a day, and over 99% of the data collected reached users like weather forecasters within 3 hours of collection. So it really was in near real time. We were studying the winds around Earth. It only had a 3-year-long mission, and it's done, I think, close to 5, almost 4 and a bit. It could keep going. It's working very well, but it's out of fuel. And that has to do with how high up, there's a lot of going on, because it's only 320 kilometers above the Earth, whereas the International Space Station, for example, on average is 400 kilometers above the Earth. So when you're closer to the Earth, you have more of the atmosphere to deal with. Gravity pulls on you a little bit more. And so the fuel, they've run out. Their time is up. Even though the spacecraft is still working, there's always an end of life, and it's always usually to do with the fuel, unless something catastrophic happened.
Very cool.
And so now it's coming down in an interesting way. So I love European Space Agency. Their graphics are always amazing. There's a lot of text, you can ignore it, but it's so nice. They're so nice to look at.
Bye Aeolus.
Bye Aeolus. Yeah. So what they're doing is they're doing this assisted controlled reentry attempt. So typically satellites, we just the term is uncontrolled and unassisted. To me, it's abandonment. We just kind of abandon them when their lives are over, and they come down when they come down. This time they're now they're bringing it down themselves. So they've brought it from the 320 kilometers at the end of its life. It was meant to, drop down to 280 kilometers naturally as it comes down. And then the scientists and the flight controllers in Germany, they take over. And so now what they're doing is they are now bringing it down in stages. So from 280 kilometers down to 150 kilometers, and then from 150 kilometers down to 120, where then they kind of lose the ability to control it at that point, and the satellite will come down and burn up in the atmosphere by 80 kilometers above the Earth. They performed the first maneuver, getting it from 280 to 250 on the 24th. The days get kind of weird because they use European, like Central European summertime, which is 9 hours ahead of us. So sometimes the days are off, but they brought it down from 280 to 250 on the 27th, or today, like early this morning. The plan was started to get it from 250 to 150, the largest drop. So it's 100 kilometers down, which is big. As of 9 a.m. this morning, our time, the first out of the 4 stages, because they're not doing one drop from 250 to 150. They did 250 to 230. They'll do 230 to, another one, and slowly get it down. Was a success. They've brought it down from 250 to 230. And that one burn lasted for 45 minutes and used up 6 kilograms of fuel. So there's only so much fuel left. So if any one of these drops uses too much, they have to reevaluate, and maybe they abandon the project and they just let it continue to fall and burn on its own. But the idea is that they will control it until they literally can't anymore, and set up the spacecraft so that it burns up over the Atlantic Ocean, and any possible debris lands in the ocean away from any cities at all.
Into Point Nemo. Looks like it's going to land.
I mean, on the globe, maybe. Yeah. It's not... the idea of like why they're doing this is because of space debris and the problems with uncontrolled reentries, right? And, if you're not controlling it, the chances of it hitting a person, an individual, is incredibly small. It's like 3 times smaller than the chance of being hit by a meteorite, which is already incredibly small. But it's still quite dangerous, and it's just like something we just shouldn't do. Like we shouldn't just let things fall out of the sky, really. There should be a plan for them. And so they're doing this to kind of set a precedent and also test to see how well it can be done, because lower atmospheric maneuvers like this are very, very difficult. The atmosphere is very thick. It's thicker, there's greater gravitational pull, and Aeolus was not built to do this. This was, developed in the 1990s when the plan for reentry was, well, it'll come back. You don't need to do that. It'll come back on its own. And so it was not built to do this. So at any given chance, any given point, there's a chance that they will have to abandon it because they simply can't control the satellite anymore, or something happens to it, or it uses more fuel than needed, or one of the burns doesn't work, right? So that's kind of their plan, kind of pushing the envelope of doing it and trying to set, a new precedent of how to deal with what we put into space. They had a press conference recently that I was reading about, and one of the scientists was saying that there's something like 10,000 spacecraft in space currently. 2,000 of them are not functional, but they're still up there. Right. And so it really ties back to when you start launching things into space, and especially in orbit around Earth, there needs to now be a plan to bring them back down. We can't just leave them there anymore. Right. Is kind of, so this new method of slowly bringing it down controlled will maybe be seen much more in the future, especially by the European Space Agency, as they're the ones who are now developing this new method of doing it.
Yeah, it sort of seems like the best methods in these cases to be the best example, because you have so many different countries and private corporations, and nobody is really forcing anyone. There's not really a whole lot of regulation, but you kind of need to be like all of us. You need to set the example. You need to be like, this is the standard we need to set for everyone because it's important and everyone needs to do it. And then eventually, hopefully, there can be some regulation, although I doubt that there can be any sustaining regulation. But you can go back and listen to some amazing webinars that we did on this every Space Debris Day in February. We have several of those on our YouTube channel. So just type in Space Debris Day on our YouTube channel and you'll find lots of amazing conversations.
No, it's yeah, the idea of getting the whole world to agree on something. I mean, we've done it before, with the chlorofluorocarbons, right? We've agreed, we've managed to start to rebuild the ozone layer. Would be nice if we could all agree on this as well. Maybe don't just abandon your spacecraft in space. Have a plan to bring it back. Yeah,
Keith says that it's a low stakes project to try out the new method. Doesn't really matter if it fails.
No, it doesn't. So the spacecraft, like the satellite itself, is not very big, right? Large debris is like rocket bodies, like those are much larger than your average satellite. And so the risk to life from the fragments that could come from this is incredibly small. And if what they're doing is successful, it's 42 times smaller, the risk to life. So it's already like it's a low stakes attempt, right? If it works, great. If it doesn't work, okay, well, we tried, but it's still good.
Awesome. Well, there we go. Those are our two big stories for today. You know what? I actually just looked up Aeolus because I knew that there was probably going to be some connection.
Oh, it's like the Greek god in charge of wind, right?
That's right. So Aeolus, the son of Hippodes, was the ruler of the winds. And there's a story in Homer's Odyssey. Did you ever read Homer's Odyssey in school?
No.
So Aeolus was the king of an island. And to ensure safe passage for Odysseus, Aeolus gave Odysseus a bag containing all the winds except the gentle west wind.
Oh, why?
I don't know. There's like these weird stories of I'm not sure. It's like, I'll give you all of this except this one thing. Don't open this bag. Of course, what do you think that they do? They open the bag because they think it's full of treasure, and then all of a sudden the winds drive them back to Aeolia, which is the island.
His island.
I know, right?
Okay.
It's such a weird story. I just reading this off of the Wikipedia page.
I guess it's to explain where the winds come from, right?
Yeah. Of course, but there's many different cultures. I've heard actually many local indigenous stories surrounding the wind as well. We actually had a show many years ago that was kind of based on that. It was very, very, very cool. And also always very strange and nebulous, because it seems like wind is one of those things that we kind of understand, but also don't really understand. I always I have this level of knowledge that I understand it to a certain point, and then is it just a chaos system? It's just, I don't understand what's going on, how it's created.
Yeah, I remember like being told that studying wind is similar to studying like air works using fluid dynamics, and at that point I
Mhm.
checked out. I was like, that's okay. Some things are I don't need to know, and that's fine.
Well, of course, I mean, I think at some point this does become very interesting when we can look at the patterns of other planets. I've been hearing some planetary scientists that on podcasts I listen to, how when they study the kind of like the gas wind sort of Neptune or
Hmm.
of Saturn, and how these patterns, give us new models, because all we have is the Earth model, and maybe there's another way that wind per se, depending if it's air or other kinds of gases, works, right? You
Yeah.
need more models to give you a better understanding of how it works.
Yeah, and I mean, like, there's so many things factor into it. Like, our air is mostly nitrogen, but how much changes if it's mostly carbon, and how thick
Mhm.
is the atmosphere? There's and how hot is the planet, or how
Right.
cold is it? Because that'll impact it as well. There's just a lot to be. It's like, yeah, wind is just the intersection of like 17 other different systems that we need to understand, is what it feels like. Like, heat and elements and stuff. Yeah.
And then, of course, that nebulous butterfly that's flapping its wings that's
Of
causing
course.
the,
Yeah.
the hurricane over here, right?
Of course.
Well, there you go. That is Ask an Astronomer for today. A bit of a quieter episode, but if you're out there and have any questions for us, we've got a last few minutes to go. I do want to tell you about a very special event that we are doing next week, Tanabata. Tanabata is the seventh month of the seventh day of the seventh month. It's a Japanese star festival. We have Miho from the UBC astronomy department. She works on dark matter, but she is also going to be our narrator for a special story celebrating Tanabata, some of the mythology around Japanese star culture. So we are doing two events actually. So on the screen here, you see the advertisement for the event we're going to be doing here in the planetarium. Miho is going to be with me and Marley in our planetarium. Full show at around 7 p.m. in our Star Theater. And then we'll have the observatory open for stargazing. And then the next day, we will be at the Powell Street Festival, which is down in Oppenheimer Park. And we will be bringing our portable planetarium. We'll be doing shorter versions. Miho and myself will be there doing the short version of the Tanabata mythology. So if you are interested in Japanese mythology as it ties to this star festival, if you've never heard it before, this is a fantastic way to dive into it. We just did a rehearsal last night. We saw a look at some of the imagery that was put together by Raymond Nakamura, who is a local museum curator and storyteller himself, and also an artist. Did some cool cartoons for us and that we put into the Star Theater. And then Miho, of course, is all going to talk about that, as well as her research, which is also very cool, all around dark matter.
No, I'm very excited. It'll be fun.
Awesome. So stay tuned for that. Go to our website to get your tickets, spacecenter.ca. We will be back in 2 weeks. Our next episode is going to be on August the 10th. And of course, that is going to be all around the Perseids. So it is getting to that time. Of course, every year they come around. We know you have lots of questions about the Perseids. So come to that Ask an Astronomer or come to our event that we're going to have. We're going to have another couple events that weekend as well here at the Space Center, also out at Aldergrove Regional Park. And then, in fact, we're going to have Miho back in 2 weeks after that, at the end of August, to actually delve into more of her research. So some really fun episodes coming up. Make sure that you subscribe to this channel so you get all of the notifications when we are going live, 4 p.m. every second Thursday. We will see you then in a couple weeks. Take care, everyone.